Children, in this video we will see the relation between zeros and coefficient of a polynomial. Suppose we have a linear polynomial whose standard form is px is equal to ax plus b. Then the zero of this linear polynomial will be x is equal to minus b upon a. Okay? But if we are given a quadratic polynomial of the standard form ax square plus bx plus c, then for the degree 2 it has two zeros. So here, to find out the relation between the zeros and coefficient of a polynomial, if it is quadratic, then let alpha and beta be the zeros of quadratic polynomial. So for this polynomial ax square plus bx plus c, we have assumed alpha and beta be the two zeros of the quadratic polynomial. So the relation between these zeros and the coefficient of these polynomial coefficient of px is equal to ax square plus bx plus c are a and b. A and b are the coefficient. A is the coefficient of x square, b is the coefficient of x, whereas c is a constant. So here a and b are the coefficients of x square and x, and c is a constant. So now we have to see that what is the relation between the zeros of the polynomial and the coefficients. So here the relations are defined in two ways. First relation is given by sum of zeros, alpha plus beta. Okay, and this relation of zeros, sum of zeros, is given by alpha plus beta is equal to minus coefficient of x upon coefficient of x square. I repeat, the relation sum of zeros alpha plus beta is equal to minus coefficient of x upon coefficient of x square. That implies alpha plus beta is equal to minus coefficient of x is b upon coefficient of x square is a. That means the relation sum of the zeros is given by alpha plus beta is equal to minus b upon a. The second relation product of zeros. Product of zeros, that is alpha into beta, written as alpha dot beta is equal to, now this relation is given by alpha into beta is equal to constant term upon coefficient of x square. That implies alpha into beta is given by c, which is the constant here. C is the constant upon coefficient of x square, which is equal to a. So alpha into beta is given by c upon a. So we have seen the two relations between the zeros and the coefficient. First is alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a. Now let us try to understand this with the help of an example. I am taking here an example, px is equal to x square plus 5x plus 6. Okay, x square plus 5x plus 6 is a quadratic polynomial, and by comparing with standard form, which is px is equal to ax square plus bx plus c. So if you compare both of these, you will find we get a, which is equal to 1. Here coefficient of x square is 1, so a will be equal to 1. B is equal to 5 and c is equal to 6. So here we have got the values of coefficients and the constant. Now, to find the zero of this polynomial, either we can solve it by using any identity if it is applicable, or we can solve it by the method of middle term splitting, as we all have studied this in class 8th and class 9th. So let us factorize this by the method of middle term splitting. So we have x square plus 5x plus 6. We can write this as x square plus 2x plus 3x plus 6. That is, by taking common x from these two, we get x in bracket x plus 2, plus taking common 3 from these two, we get x plus 2. So here x plus 2, x plus 3 are the two factors. Now since we are finding out the zeros of the polynomial, so if x plus 2 is equal to 0 gives you x is equal to minus 2, and if x plus 3 is equal to 0 gives you x is equal to minus 3. So x is equal to minus 2 and minus 3 are the two zeros of the polynomial x square plus 5x plus 6. Now as these two are the zeros, so we can assume any of these as alpha and beta. So let alpha is equal to minus 2 and beta is equal to minus 3. We can also take alpha equal to minus 3 and beta equal to minus 2, which will not affect our result. So let us now satisfy the relation. The first relation we have is alpha plus beta is equal to minus b upon a. So let us see whether this relation is applicable here or not. We have got the values of alpha and beta, which is equal to minus 2 plus minus 3, which is equal to minus the value of b, which we had, b is equal to 5 and a is equal to 1. So here minus 2 plus minus 3 is equal to minus 5 upon 1. That implies minus 2 plus minus 3 is equal to minus 5 is equal to minus 5. Hence, the relation satisfies. Second relation we have is alpha into beta is equal to c upon a. That is, now alpha into beta, that is minus 2 into minus 3 is equal to the value of c, which we have is 6, and the value of a is 1. That is equal to 6 upon 1. So minus 2 into minus 3 is equal to 6, which is equal to 6. That means the relation is satisfied.